Authentication and authorization are quite important aspects of web security that a web developer needs to know. When you're trying to implement these things in your project, you might have stumbled upon a term called JWT. If you're a self-learner or a beginner, you might have found it difficult to understand what exactly does JWT do and what purpose does it solve. Hi everybody, this is Sudarshan and I'm here to discuss about JSON Web Tokens or JWTs for short. This is a beginner friendly video, so we will be covering everything from scratch. Let's say you want to transfer a message to your friend with the help of the internet, but you're scared that the message might get tampered during the transfer. So your friend needs to verify whether the message that you sent was either original or was it modified during the transfer. So here now the question comes, how does your friend verify the authenticity of the message? First what you do is you write your message, let's call it M, and then you append a secret code to the message. Remember, the secret code should really be long, at least of size 256 bits. And also the secret code should only be known to you and also to your friend, right? So now the obtained string becomes M plus K. Now what you do is you compute the hash of M plus K. Let's call it R. Now if you look at here, the hash is linked both to the message and also to your secret code K. Now what happens is that even if there is a slightest modification to the message M or to the secret code, then the computed hash completely changes. So we can say that for two different messages, the hash cannot be the same. It will always be different. Now after obtaining the computed hash, that is R, you send both the message M and also the computed R, that is the hash, to your friend. This process is called appending a digital signature to the document, or in this context to your message. Here the computed hash, that is R, is actually your digital signature. This is because in order to compute the hash, you are using the secret code K, which only you and your friend knows. So along with the message M, you are sending your digital signature R, that is signed to the message M. Now this is sent to your friend so that he can verify two things. The first is that he need to verify whether the message that he received is actually sent by you. And the second thing he needs to verify is that the message is not tampered down the way during the transfer. At the receiver side, your friend follows a similar process to verify the authenticity and the integrity of the message. He takes the obtained message M, appends the same secret code K you had used earlier, and then computes the hash. If this computed hash matches the digital signature you had sent, it means the message hasn't been tampered with. If the message were tampered with, the computed hash would be completely different and wouldn't match the digital signature. This verifies the first thing, the integrity of the message. Now to compute the hash, your friend uses the same secret code K. If he used a different secret code, the computed hash would be different and wouldn't match the digital signature you sent. Since it actually matches the digital signature, it can only mean one thing to him. It is indeed you who sent the message. This is exactly how a JSON Web Token works. Now let us look at the format of a JWT. It consists of three sections: header, payload, and the signature part, which are each divided by a period. The header consists of the hashing algorithm. The payload consists of the actual message that you need to send. Both of them are first written in JSON format, which is called the JavaScript object notation, and then it is base64 encoded. Remember, the header and the payload are only encoded and it is not encrypted. That means anyone who gets access to this token can read the payload and the message present within it. Now in order to sign it or create the signature part, you take the message and a secret code, then you compute the hash using the same algorithm that is mentioned in the header section. Now once you send this token to someone, they verify it using the verification process as mentioned earlier. They take the payload and they append a secret code K to it, which is mentioned over here, your 256-bit secret, and they use the same hashing algorithm as mentioned in the header section to compute the hash. If it matches the signature which is given with the JWT token, then That means the signature is verified and the JWT is valid. So this is how JWTs work. In an upcoming video, I'll be talking about the applications of JWTs, especially how JWTs can be used to authenticate and authorize a user. We will also be talking about the access and refresh tokens and also the vulnerabilities that are concerned with implementations of JWTs for authentication.